Good day, everyone. Welcome to today's lecture on implementing an Oculus app, a journey into virtual reality. I am Associate Professor Che Wei Lin from the Department of Biomedical Engineering at National Cheng Kung University. This course is a collaborative effort between the Department of Biomedical Engineering, BME, the Medical Device Innovation Center, MDIC, and National Cheng Kung University, NCKU. Today, we will embark on an exciting journey into the world of virtual reality development, specifically focusing on Oculus app implementation. Whether you're a beginner or have some experience in VR development, this course will provide you with valuable insights and practical knowledge to help you create immersive VR applications. Throughout this lecture series, we'll cover everything from the basics of VR technology to advanced implementation techniques. We'll explore the Oculus development environment, learn about best practices, and understand how to create engaging VR experiences. The illustration you see on the slide represents the convergence of AI, healthcare, and technology, areas where VR applications are making significant impacts. As we progress through this course, you'll see how these elements come together in practical applications. Let's begin our journey into the fascinating world of virtual reality development. Are there any questions before we dive into the main content? Let me begin by introducing you to the fascinating realm of virtual reality development. When we talk about VR development today, we're not just discussing a technology, we're exploring a gateway to endless possibilities. The image you see on the right perfectly illustrates the kind of immersive environments we'll be learning to create. Those vibrant blues and dynamic visuals represent the kind of cutting-edge experiences we'll be building together. I'm truly excited to be your guide on this journey into Oculus app development. Having worked extensively in this field, I understand both its complexities and its incredible potential. My goal is to break down these complexities into understandable, manageable pieces, making VR development accessible to each one of you. Throughout this course, we'll unveil the secrets behind creating compelling VR applications. We'll explore everything from basic concepts to advanced techniques, ensuring you have all the tools needed to bring your virtual reality ideas to life. As we step into this virtual odyssey together, remember that we're not just learning about technology, we're unlocking the future of human-computer interaction. The skills and knowledge you'll gain here will position you at the forefront of this revolutionary technology. Let's begin this exciting journey into the world of VR development, where the only limit is your imagination. Shall we proceed to our next topic? Let's begin with a fundamental understanding of virtual reality. This introduction will cover 4 key aspects that form the foundation of our journey into VR development. First, let's define what virtual reality actually is. At its core, VR is a transformative technology that transports users into fully immersive digital worlds. Unlike traditional media, VR provides distinct sensory experiences that engage multiple senses, creating a feeling of presence that's unprecedented in digital technology. Moving on to VR applications, we're seeing an incredible expansion of use cases. While gaming might be the most well-known application, VR's reach extends far beyond entertainment. From medical training simulations to architectural visualization, from educational experiences to industrial design, VR is fundamentally transforming how we interact with digital content. The evolution of VR is particularly fascinating. What many might not know is that VR's history dates back further than you might expect. From the earliest stereoscopes of the 1800s to the cutting-edge headsets we have today, VR has undergone remarkable transformation. Understanding this evolution helps us appreciate where we are and where we're heading. Finally, let's discuss current trends. VR is evolving at an unprecedented pace. We're seeing rapid developments in areas like hand tracking, wireless technology, eye tracking, and increased resolution. Staying informed about these trends is crucial for anyone working in VR development, as they shape both our present capabilities and future opportunities. As we move forward in this course, these foundational concepts will help you better understand the technical aspects of VR development we'll be covering. Does anyone have any questions about these basic concepts before we move forward? Now, let's talk about Oculus, a company that has revolutionized the VR industry. Their story is not just about technology, it's about vision, innovation, and transformation. Let's start with the Oculus genesis. What makes this story particularly fascinating is how it began, as a Kickstarter campaign in 2012. Palmer Luckey, then just 19 years old, launched a crowdfunding campaign that would eventually raise $2.4 million, far exceeding the original $250,000 goal. This tremendous success caught the attention of major players in the tech industry, leading to Facebook's acquisition of Oculus for $2 billion in 2014. This transformation from a crowd-funded project to a tech giant's strategic investment shows the incredible potential that investors and industry leaders saw in VR technology. Looking at Oculus products, we see a carefully crafted ecosystem. The Oculus Rift pioneered PC-based VR experiences, setting new standards for immersive gaming in professional applications. The Quest series revolutionized the industry by introducing standalone VR, freeing users from PC tethering while maintaining high-quality experiences. The Oculus Go, while discontinued now, played a crucial role in making VR more accessible to the masses through its affordable price point and ease of use. Speaking of industry impact, Oculus has been more than just a participant in the VR space, they've been a driving force in shaping it. Their contributions go beyond hardware innovations. They've established development standards, created powerful SDKs, fostered a vibrant developer community, and perhaps most importantly, shown that VR can be both powerful and accessible to everyday users. As we delve deeper into Oculus development in this course, understanding this background will help you appreciate why certain technical decisions were made and how they influence the way we develop for the platform. Are there any questions about Oculus's journey or its impact on the VR industry? Let's explore the Oculus ecosystem, which consists of three key pillars that work together to create a comprehensive VR platform. First, let's look at hardware exploration. Oculus has consistently pushed the boundaries of VR hardware design. Their headsets are engineered for both comfort and performance, featuring ergonomic designs that allow for extended use sessions. Beyond the headsets themselves, Oculus has developed intuitive controllers that provide natural interaction within VR environments. This attention to hardware design sets the foundation for truly immersive VR experiences. The touch controllers, for instance, have become industry standards for how we interact in virtual spaces. Moving to the software hub, this is where the magic really happens. The Oculus ecosystem is powered by three main software components. The Oculus app serves as the central control center for users, managing their VR experiences and settings. The Oculus Store provides a curated marketplace for VR content, ensuring quality and accessibility. And perhaps most importantly for us as developers, the Oculus SDK provides the tools and frameworks necessary to create compelling VR applications. These three elements work in perfect harmony to deliver seamless experiences for both users and developers. Lastly, but certainly not least, is the Community Connect aspect. What truly sets Oculus apart is its vibrant community of developers, creators, and users. The developer forums are active with knowledge sharing and problem-solving discussions. Regular developer conferences, online resources, and extensive documentation provide the support needed for successful VR development. This strong community aspect ensures that developers never have to solve problems in isolation. As we proceed with our development journey, you'll be interacting with all these elements of the ecosystem. Understanding how they work together will be crucial for creating successful VR applications. Does anyone have questions about any particular aspect of the Oculus ecosystem? Now, let's dive into understanding what makes VR development unique and what you'll need to succeed in this field. Let's start with VR uniqueness. Virtual reality development is fundamentally different from traditional app development in several key ways. First, we're working in three-dimensional space rather than on a 2D screen. This means we need to consider user movement, spatial awareness, and depth perception. We also need to account for user comfort and potential motion sickness. Unlike traditional apps, VR applications must maintain high frame rates and low latency to prevent disorientation. These unique challenges require specific solutions and approaches that we don't typically encounter in conventional app development. Moving on to the required skill set, VR development demands a diverse range of abilities. Beyond traditional programming skills, you'll need to understand 3D modeling and animation, spatial audio design, and user interface design in three-dimensional space. You'll also need to grasp concepts like quaternions for rotation, physics simulations, and optimization techniques specific to VR. Perhaps most importantly, you'll need to develop an intuition for what makes a VR experience comfortable and engaging for users. Finally, let's look at development tools. The VR development landscape offers several powerful platforms and tools. Unity and Unreal Engine are the most popular game engines for VR development, each with their own strengths. We'll be exploring these tools in detail, along with specific VR development SDKs and debugging tools. However, I want to be upfront about the challenges you'll face. VR development can be complex, and you'll encounter unique debugging scenarios and performance optimization challenges. But don't worry, we'll tackle these challenges together throughout this course. Does anyone have questions about these aspects of VR development before we move on to more specific technical details? Now, let's focus on setting up your VR development environment. As you can see in the image on the left, we'll be working with advanced VR controllers and hardware, but first, we need to ensure our development environment is properly configured. Let's start with essential software. For VR development, you'll need two primary components, a game engine and the Oculus SDK. For the game engine, you have two excellent options, Unity or Unreal Engine. Unity is particularly popular for its ease of use and extensive VR development community, while Unreal Engine is known for its powerful graphics capabilities. The Oculus SDK will provide the necessary tools and frameworks to interface with Oculus hardware. Both are essential for creating VR applications. Moving on to the installation guide, I'll walk you through a detailed step-by-step process. We'll cover installing your chosen game engine, setting up the Oculus SDK, configuring development tools and dependencies, installing necessary plugins and packages. This systematic approach will ensure you don't miss any crucial components. Finally, let's talk about configuration and testing. This is a critical step that many developers rush through, but proper configuration can prevent numerous issues down the line. We'll cover optimizing your development environment settings, configuring your VR hardware for development, running initial tests to verify everything is working correctly, troubleshooting common setup issues. Remember, a well-configured development environment is the foundation for successful VR development. In our next hands-on session, we'll go through each of these steps together to ensure everyone has a working development environment. Are there any questions about the setup process? Now we're going to dive into the Oculus SDK, which is the backbone of VR development for Oculus platforms. As you can see in the image above, the SDK enables us to create sophisticated 3D tracking and rendering capabilities, visualized here through the point cloud representation of user movement. Let's start with SDK features. The Oculus SDK provides developers with a comprehensive suite of tools and capabilities. These features include advanced head and hand tracking systems, sophisticated rendering pipelines optimized for VR, built-in physics interactions, spatial audio management, performance optimization tools. These features are designed to empower developers to create immersive and responsive VR experiences without having to build everything from scratch. Moving on to SDK components, it's crucial to understand the building blocks available to us. The SDK is comprised of several key elements: core libraries for fundamental VR operations, APIs for hardware interaction and control, utility functions for common VR tasks, debug tools for development. Understanding how these components work together will be essential for efficient development. Finally, let's talk about getting started. We'll begin with the basics of SDK operations, including setting up your first VR scene, implementing basic head tracking, handling controller input, managing VR camera behavior. This foundation will prepare you for more advanced development tasks we'll cover later. As we proceed with hands-on development, you'll gain practical experience with each of these aspects. Would anyone like me to clarify any particular aspect of the SDK before we move forward? Let's delve deeper into the specific capabilities of the Oculus SDK and explore how these features can enhance your VR development process. Starting with main functionalities, the Oculus SDK offers a comprehensive set of core capabilities. These include advanced tracking systems that provide sub-millimeter accuracy for head and hand movements, sophisticated rendering techniques optimized for VR performance, built-in social features for multiplayer experiences, advanced audio spatialization for immersive sound, Guardian system integration for user safety. Each of these functionalities has been carefully designed to address specific challenges in VR development. Looking at the advantages for developers, the SDK provides a robust framework that significantly streamlines the development process. Instead of building everything from scratch, developers can utilize pre-built components for common VR interactions, take advantage of optimized rendering pipelines, access built-in debugging and performance monitoring tools, leverage cross-platform compatibility features. These advantages can dramatically reduce development time and improve the quality of your VR applications. Finally, let's examine real-world usage through some inspiring examples. Consider Beat Saber, which uses the SDK's precise tracking for its rhythm-based gameplay, or Job Simulator, which demonstrates excellent interaction systems. Medical training applications utilize the SDK's detailed hand tracking for surgical simulations, while architectural visualization tools leverage the rendering capabilities for photorealistic environments. These examples show how developers are pushing the boundaries of what's possible with the Oculus SDK. Would anyone like to hear more specific details about any of these capabilities or examples? Now let's take a deeper look at the architecture of the Oculus SDK, understanding how its various components work together to create powerful VR experiences. First, let's examine the SDK structure. The Oculus SDK is built in layers, each serving a specific purpose. At the lowest level, we have the hardware abstraction layer, which communicates directly with the Oculus hardware. Above that, we find the core systems layer, handling tracking, rendering, and basic input. Next is the feature layer, providing higher-level functionalities like social features and avatar systems. Finally, we have the application layer, where your VR applications interact with the SDK. Understanding this layered architecture is crucial for efficient development and troubleshooting. Moving on to component interaction, we'll explore how these different parts work together seamlessly. For example, when a user moves their head, the tracking system coordinates with the rendering pipeline. Input from controllers flows through multiple layers before reaching your application. The Guardian system constantly communicates with various components to ensure user safety. This intricate dance of components happens in milliseconds to maintain the illusion of presence in VR. Finally, let's discuss staying updated. In the fast-moving world of VR development, keeping your applications up to date is crucial. Here's what you need to know. Regular SDK updates bring performance improvements and new features. Version compatibility needs to be maintained across all components. Breaking changes sometimes require code adjustments. Testing is essential after each significant update. I'll share some best practices for managing updates while maintaining stable applications. Does anyone have questions about the SDK architecture or update management? Let's discuss one of the most critical aspects of VR development, designing experiences with the user in mind. Creating compelling VR applications isn't just about technical implementation, it's about crafting experiences that users will find both engaging and comfortable. Let's start with user experience in VR. When envisioning a compelling VR experience, we need to consider several key factors. Immersion, how do we make users feel truly present in the virtual world? Interaction, what are the most natural ways for users to interact with virtual objects? Feedback, how do we provide clear, intuitive feedback for user actions? Comfort, how long can users comfortably engage with our application? Remember, what works in traditional 2D applications doesn't always translate well to VR. Moving on to UX challenges, we face several unique hurdles in VR development. Motion sickness is perhaps our biggest challenge. We need to carefully manage user movement and camera controls. UI design in 3D space requires entirely new approaches. Traditional flat menus don't always work in VR. Physical comfort becomes a major consideration, including the weight of the headset and duration of use. Spatial awareness and depth perception need to be carefully managed. Finally, let's explore best practices for creating comfortable and fulfilling VR experiences. Keep user sessions manageable with appropriate breakpoints. Provide multiple movement options to accommodate different comfort levels. Design UI elements at comfortable viewing distances and angles. Use spatial audio to enhance immersion naturally. Include clear visual indicators for boundaries and interactive elements. Would anyone like to share their experiences with VR comfort issues or discuss specific UX challenges they've encountered? Now let's discuss the fundamental principles of VR design. As you can see in the image on the right, VR allows for natural interaction with virtual objects, much like how we interact with physical museum displays. This kind of intuitive interaction is exactly what we're aiming to achieve in VR design. Let's start with design principles, the cornerstones of effective VR experiences. Immersion, creating a sense of being completely surrounded by and engaged in the virtual world. Presence, making users feel they're physically there in the virtual space. Interactive engagement, ensuring natural and intuitive ways to interact with the virtual environment. These principles aren't just theoretical concepts, they're essential elements that make or break a VR experience. Moving to applying principles, let me share some concrete tips for implementation. Design interactions that mirror real-world movements. Use spatial audio to enhance the sense of presence. Create consistent and predictable physics behavior. Maintain proper scale and proportion in your virtual environments. Implement gradual transitions to maintain immersion. These practical applications help create a seamless and engaging VR experience. Finally, let's address avoiding pitfalls. Common mistakes in VR design include inconsistent scale references, sudden camera movements, overwhelming visual complexity, poor performance optimization, unintuitive interaction patterns. By being aware of these potential issues early in development, we can design better, more user-friendly VR experiences. Looking at our museum example in the image, notice how the interactive elements are placed at a natural height and distance for user interaction. This is the kind of thoughtful design consideration we need to apply in all VR applications. Does anyone have questions about these fundamental principles? Now let's focus on achieving excellence in Oculus development. As you can see from the Oculus headset in our image, we're working with sophisticated hardware that demands equally sophisticated software practices. Let's start with how to run smoothly. Performance is absolutely critical in VR applications. Maintain a consistent frame rate of at least 72 FPS for comfortable viewing. Implement efficient asset loading and memory management. Optimize your rendering pipeline to reduce latency. Use level of detail, LOD, systems for complex scenes. Implement proper threading for resource-intensive tasks. These technical considerations ensure your app runs with clockwork precision. Next, let's address user safety, which is paramount in VR development. Implement clear boundary systems to prevent physical collisions. Design comfortable movement mechanics to minimize motion sickness. Include regular break reminders for extended sessions. Ensure all UI elements are at comfortable viewing distances. Consider different physical abilities in your interaction design. Remember, a safe experience is a prerequisite for an engaging one. Finally, let's examine Oculus standards. Meta has established clear guidelines for app development. Performance benchmarks that must be met. Content guidelines for the Oculus Store. Best practices for user interaction. Accessibility requirements. Social features implementation standards. Following these guidelines not only improves your app's quality but also increases its chances of store approval. Looking at our Oculus hardware image, notice the attention to detail in its design. We need to match this level of polish in our software development. Are there specific aspects of these best practices you'd like to explore further? Now we're going to get hands-on and create our first VR scene. As you can see in the image on the left, VR can create immersive environments where users feel truly present in the virtual space. Let's break this process down into manageable steps. Let's start with basic scene setup. I'll guide you through the essential steps. Setting up the VR camera rig correctly. Establishing the proper scale for your virtual environment. Creating basic environmental elements like ground plane and lighting. Adding simple interactive objects. These fundamentals will form the foundation of any VR experience you create. I'll demonstrate each step live, and you'll receive code snippets that you can modify and expand upon. We'll examine how each component contributes to the overall experience. Finally, for testing your scene, we'll cover critical optimization and testing procedures. Performance benchmarking. Frame rate optimization. Interaction testing. Comfort level assessment. Cross-device compatibility checking. Remember, the scene we see in our reference image shows people comfortably engaged in a VR experience. That's our goal for every scene we create. We want users to feel naturally present in our virtual environments. Would anyone like me to clarify any of these steps before we begin the practical demonstration? Now we're going to explore one of the most critical aspects of VR development, mastering input handling with Oculus controllers. The way users interact with your VR application can make or break their experience. Let's begin with Oculus controllers. These sophisticated devices offer several distinctive features. 6 degrees of freedom tracking for precise movement detection. Capacitive touch sensors for finger position tracking. Multiple buttons and triggers for varied interactions. Haptic feedback capabilities for tactile responses. Accelerometers for gesture recognition. Understanding these capabilities is essential for creating intuitive interactions. Moving on to user interaction techniques. Here's how we can leverage these controllers effectively. Design natural grabbing and manipulation mechanics. Implement pointing and selection systems that feel intuitive. Create gesture-based commands that users can learn easily. Utilize haptic feedback to enhance immersion. Ensure consistent behavior across different interaction types. The goal is to make interactions feel so natural that users forget they're using controllers. Finally, let's examine an effective case study. Take the example of Beat Saber. The game uses precise controller tracking for sword movements. Haptic feedback provides satisfying impact sensations. Simple but effective gesture controls for menu navigation. Consistent interaction patterns throughout the experience. Immediate and clear feedback for all user actions. This case study demonstrates how well implemented input handling can create an engaging and intuitive VR experience. Would anyone like to explore any of these aspects in more detail? Now let's explore how to effectively integrate 3D models and environments into your VR applications. This is where your virtual worlds really come to life. Let's start with asset import. When selecting and importing 3D assets, consider these guidelines. Ensure proper model optimization with appropriate polygon counts. Check for proper UV mapping and texture resolution. Verify scale consistency across all assets. Consider load, level of detail, variations for performance. Make sure your file formats are compatible with the Oculus platform. Remember, well-chosen assets form the foundation of your virtual environment. Moving on to scene dynamics. Creating engaging environments goes beyond just placing static models. Implement interactive elements that respond to user actions. Add ambient animations to create a living environment. Use particle systems for atmospheric effects. Include sound design to enhance spatial awareness. Create meaningful environmental storytelling through object placement. These elements work together to create a sense of presence and immersion. Finally, let's discuss performance equilibrium. This is perhaps the most crucial balancing act in VR development. Monitor draw calls and optimize where necessary. Implement efficient lighting and shadow techniques. Use texture atlasing to reduce memory usage. Consider using baked lighting where appropriate. Implement proper occlusion culling. The goal is to achieve the best possible visuals while maintaining the smooth performance that VR demands. Would anyone like me to elaborate on any of these aspects of 3D integration, particularly regarding performance optimization techniques? Let's explore one of the most crucial aspects of VR development, movement mechanics. As you can see in our reference image on the right showing a complex anatomical visualization, movement in VR needs to be precise and comfortable, especially for educational and medical applications. Let's start with types of movement. There are several approaches to VR locomotion. Teleportation, the most comfortable option for many users, allowing instant position changes. Smooth locomotion, continuous movement like traditional gaming. Room scale walking, physical movement within the track space. Node-based movement, predefined points for navigation. Each has its advantages and best use cases, and we need to choose wisely based on our application's needs. Moving on to movement implementation. This is critical for user comfort. Implement acceleration curves to prevent motion sickness. Add visual reference points during movement. Include comfort vignetting during rapid movement. Provide clear indicators of movement boundaries. Allow users to customize movement settings. Remember, stable and comfortable movement is essential for maintaining presence in VR. Finally, let's look at code for movement. We'll examine how to implement these mechanics while maintaining performance and user comfort. Looking at our anatomical visualization example, notice how precise movement control is essential for examining detailed 3D models. Would anyone like to explore any particular movement type in more detail? Now let's explore advanced interaction techniques that can take your VR applications to the next level. These sophisticated approaches can dramatically enhance user engagement and immersion. Let's begin with gesture recognition. This is where VR truly shines. Implementation of precise finger tracking for natural gestures. Development of intuitive hand poses for specific actions. Creation of gesture-based command systems. Integration of haptic feedback for gesture confirmation. Advanced algorithms for gesture prediction and smoothing. The goal is to make interactions feel as natural as possible, just like manipulating objects in the real world. Moving on to interactive elements. The key is transforming static environments into living, responsive spaces. Creating physics-based interactions with objects. Implementing realistic material responses. Designing contextual environmental reactions. Building chain reactions in complex interactions. Developing intelligent object behaviors. These elements make your VR world feel alive and responsive to user actions. Finally, let's examine some inspirational case studies. Half-Life, Alex with its groundbreaking physical interaction system. Job Simulator for its intuitive object manipulation. Medical training applications with precise hand tracking. Architectural visualization tools with natural interaction methods. These examples show how advanced interactions can create truly compelling VR experiences. Would anyone like to explore any of these interaction techniques in more detail? Perhaps we could dive deeper into a specific case study that interests you? Let's dive into one of the most crucial yet often overlooked aspects of VR development, spatial audio. As you can see in our reference image, even in a social VR environment, audio plays a vital role in creating natural interactions and spatial awareness. Let's start with audio's role in VR experiences. Sound provides crucial spatial orientation cues. Audio feedback reinforces user interactions. Environmental sounds create atmosphere and presence. Distance-based audio helps with depth perception. Directional audio guides user attention naturally. Remember, while VR is often thought of as a visual medium, audio is equally important for creating true immersion. Moving to spatial audio crafting, this is where the technical expertise comes in. Implementing HRTF, head-related transfer function, for realistic 3D sound. Creating accurate sound attenuation over distance. Managing audio occlusion and reflection. Handling dynamic audio sources in 3D space. Optimizing audio processing for performance. These technical elements combine to create convincing spatial audio experiences. Finally, let's cover audio best practices. Maintain appropriate volume levels across all sounds. Implement priority systems for multiple audio sources. Use audio cues to supplement visual feedback. Consider performance impact of simultaneous audio sources. Test audio in different virtual environments. Looking at our example image, notice how social VR environments need careful audio consideration for natural communication. Does anyone have questions about implementing spatial audio in their VR applications? Now let's tackle one of the most challenging aspects of VR development, designing effective user interfaces. As you can see in the image above, which shows a traditional 2D interface design, we need to completely rethink how interfaces work when transitioning to 3D space. Let's start with VR UI challenges. Depth perception and comfortable viewing distances. User interaction in three-dimensional space. Reading text and viewing detailed information in VR. Managing user fatigue during extended interface use. Spatial organization of UI elements. These challenges require innovative solutions that go beyond traditional 2D interface design principles. Moving on to UI best practices. Keep interactive elements within comfortable reach zones. Use spatial positioning to create intuitive hierarchies. Implement clear visual feedback for all interactions. Design with proper scale and depth in mind. Consider ergonomics and user comfort. Remember, in VR, every interface element needs to feel natural and spatially coherent. Finally, let's examine some UI excellence examples. Oculus Home's intuitive menu system. Beat Saber's minimal yet effective in-game interface. Tilt Brush's innovative tool selection system. Virtual Desktop's workspace management. Professional VR training applications information display. Looking at these examples, we can learn how successful VR applications have solved complex UI challenges. Would anyone like to discuss specific UI challenges they're facing in their own VR projects? Let's focus on a crucial aspect of VR development, performance optimization. In VR, performance isn't just about smooth operation, it's about preventing user discomfort and maintaining immersion. Let's start with performance metrics understanding. Frame rate, the golden standard is maintaining 90 FPS, frames per second. Motion to photon latency, keeping this under 20 milliseconds. Resolution requirements for different devices. GPU and CPU performance budgets. Memory utilization targets. Understanding these metrics is essential because they directly impact user experience. Moving on to optimization tips and strategies. Here are some key approaches. Implement efficient load, level of detail, systems. Use proper batching techniques for rendering. Optimize shader complexity and draw calls. Employ texture atlasing and compression. Implement proper occlusion culling. These strategies can significantly improve your application's performance. Finally, let's explore performance analysis tools. Oculus Debug Tool for performance monitoring. Unity Profiler for detailed performance analysis. GPU visualization tools. Memory profiling utilities. Frame timing analyzers. Remember, VR applications require consistent high performance to maintain user comfort. Poor performance doesn't just affect the experience, it can make users physically uncomfortable. Would anyone like me to elaborate on specific optimization techniques or performance monitoring tools? Now let's tackle debugging in VR development, which presents unique challenges compared to traditional software debugging. As our illustration suggests, some issues may only become apparent over time or through repeated testing. Let's start with common issues that developers frequently encounter. Tracking inconsistencies and drift. Performance drops and frame rate issues. Input lag and controller response problems. Render pipeline errors. Spatial audio glitches. Understanding these common problems helps us develop faster solutions when we encounter them. Moving on to debugging mastery. VR debugging requires specialized approaches. Using in-VR debugging tools and overlays. Implementing logging systems for tracking issues. Setting up proper testing environments. Creating debug visualization tools. Establishing systematic testing procedures. The key is to develop a structured approach to identifying and resolving issues. Finally, let's examine real-world solutions through case studies. How a major VR game solved their tracking latency issues. Solutions for common performance bottlenecks. Fixing spatial audio synchronization problems. Resolving user comfort issues. Debugging multiplayer VR interactions. Remember, debugging in VR often requires you to balance between being in the headset and using external tools. The challenge is maintaining proper debugging workflows while dealing with the unique aspects of VR development. Would anyone like to share their experiences with particular VR debugging challenges they faced? Now we've reached the final and crucial step of your VR development journey, submitting your application to the Oculus Store. This process requires careful attention to detail and thorough preparation. Let's start with submission know-how. The Oculus Store has specific policies and requirements. Technical requirements including performance benchmarks, content guidelines and age rating considerations, privacy policy and data handling requirements, user safety and comfort guidelines, documentation requirements for store listing. Understanding these policies is crucial for a successful submission. Moving on to packaging mastery. Here's how to prepare your app. Optimize your build for the target Oculus platform. Prepare all required store assets, icons, screenshots, videos. Create compelling store descriptions and marketing materials. Test your package thoroughly on target devices. Ensure all necessary permissions are properly implemented. Proper packaging can significantly smooth the submission process. Finally, let's discuss review navigation. Here are tips for a successful review. Conduct thorough internal testing before submission. Provide clear documentation for reviewers. Be responsive to reviewer feedback. Have a plan for addressing potential issues. Prepare for multiple review cycles if necessary. Remember, getting through the store submission process is your final hurdle to reaching users. Taking time to properly prepare can save weeks of back and forth with reviewers. Does anyone have specific questions about the submission process or store requirements? Let's discuss quality assurance and testing for VR applications. As you can see in our reference image showing a VR testing session, proper testing requires both technical evaluation and real user interaction. Let's begin with VR testing approaches. Automated testing for performance metrics. User experience testing with different user groups. Compatibility testing across various Oculus devices. Stress testing for performance under load. Regression testing after updates. Each methodology serves a specific purpose in ensuring overall quality. Moving to QA best practices. Establish clear testing protocols. Create comprehensive test cases covering all features. Document bugs and issues systematically. Implement regular testing cycles. Maintain a consistent testing environment. These practices help maintain high standards throughout development. Finally, let's focus on user feedback integration. Set up proper feedback channels. Conduct structured user testing sessions. Analyze and prioritize user feedback. Implement iterative improvements. Track user satisfaction metrics. Looking at our testing image, notice how direct user observation during testing can reveal issues that might not be apparent through technical testing alone. This combination of technical QA and user testing is essential for creating polished VR experiences. Would anyone like to share their experiences with VR testing or discuss specific testing challenges they've encountered? As we conclude our journey into VR development, let's look ahead to the future of this exciting technology. As shown in our image, VR hardware continues to evolve, becoming more sophisticated and user-friendly. Let's explore the innovation continuum first. Next-generation display technologies with higher resolution and wider field of view. Advanced haptic feedback systems for more realistic touch sensations. Eye tracking integration for improved rendering and interaction. Wireless technologies advancing for better freedom of movement. AI integration for more responsive and intelligent VR experiences. These innovations are just on the horizon, ready to transform VR development. Looking at industry predictions. Growing adoption in enterprise and educational sectors. Evolution of development tools and frameworks. Increased focus on cross-platform compatibility. Emergence of new social VR platforms. Standardization of VR development practices. These trends suggest a maturing industry with expanding opportunities. Finally, considering Oculus forward thinking. Meta's continued investment in VR technology. Focus on making VR more accessible to mainstream users. Development of advanced hand and body tracking. Integration of mixed reality capabilities. Expansion of the Oculus ecosystem. As we can see from our journey through VR development, we're at an exciting point in the evolution of this technology. The skills you've learned in this course will position you well for these future developments. Does anyone have thoughts or questions about where VR technology is heading? Thank you all for your attention and active participation throughout this comprehensive journey into Oculus VR development. Today, we've covered a wide range of topics, from basic concepts to advanced implementation techniques, that will help you create compelling VR experiences. Let me briefly summarize our key takeaways. We explored the fundamentals of VR development and the Oculus ecosystem. We learned about crucial technical aspects like performance optimization and debugging. We discussed best practices for creating user-friendly and comfortable VR experiences. We examined the importance of testing and quality assurance. And we looked ahead at the exciting future of VR technology. As you can see from the international flags displayed at the bottom of our slide, VR development is truly a global endeavor, bringing together developers and creators from around the world. This diversity of perspectives and experiences enriches our development community and pushes the boundaries of what's possible in VR. I encourage you to take what you've learned today and start experimenting with your own VR applications. Remember, the Oculus development community is here to support you, and the resources we've discussed are available to help you on your journey. Thank you again for your attention, and please feel free to reach out if you have any questions about the material we've covered today. I look forward to seeing the innovative VR experiences you'll create.